Hi friends, welcome to GMK tutorials. In this video, we are going to discuss about the MOSFET basics for biasing. So, what is the necessity of current mirror circuit? Why we are using current mirror circuit in case of the common source, common drain amplifier? So, what is the basic necessity? So, for that purpose, let us go through some basics. Then you will get some glance about what is the necessity of current mirror circuit in case of a common drain or maybe common source or maybe common gate configurations point of view. Okay, so let us see. So the general representation of the MOSFET in case of the common drain configuration, that is just some resistance. So this is a ground terminal, right? So this is connected to the VDD, supply voltage VDD. So I can call this resistance is called as a RD for a drain resistance. Okay, this transistor can be treated as a M1. Suppose if it is taking a NMOS transistor, NMOS. At the same time, it is also having a input. This also has, sorry, just I will change the color. It is also having a input VGS signal. At the same time, this is a ground. So this is generally called the VGS, gate to VGS, gate to source for DC biasing. At the same time, this is a input voltage, and this is a configuration, right? Where suppose in this consideration, what is this is generally called a, we can call it a common source configuration. This figure represents a common source configuration. Here the problem is not that is nothing but if the gain of the transistor, suppose if you are taking the gain of the transistor, voltage gain A is equal to minus GM into RD. That is the voltage gain. So here the problem is that the RD value, that is nothing but, where RD is nothing but this resistance is generally called a biasing resistance. Okay, this is used for biasing point of biasing resistor. This GM is not high, so that the gain is less. In case of the GM is not high, because of the GM is a not high value, therefore obviously the gain of the corresponding MOSFET is also very less. So that is the one drawback in this case. GM is not high, increases. GM is not high, so some GM is maybe some around suppose 50. We are not getting a maximum voltage gain. So that is a drawback. So but there is, if you are thinking very closely, if you are changing the corresponding resistance RD value, then there is a possibility for getting the maximum gain. Why? Because AV is directly proportional to gain also. AV is directly proportional to RD. That means if the drain value is increases, AV is also increases. There is a one possibility for this one, right? So let us see here one more possibility for this case. Suppose if you are replacing the drain with some active element, So this is a circuit diagram for where RD is replaced with some active element. So this is nothing but PMOS transistor. This is an active element. So active element, that is nothing but here PMOS transistor is used. Okay, PMOS transistor. So I think all of you having why you are using PMOS. So in case of the PMOS circuit, so this is generally called as an active element. I think all of you having some basic idea. So PMOS is used as a pull-up network in case of the CMOS inverter and all those things, right? So I think all of you having that kind of a basic idea, I hope, right? At the same time, so here also there is a problem. Suppose is there any variations in the VGS value? Here the active element is also depends on the biasing values. Is there any variations in the corresponding value? There may be changes in the gain also. So from this you have to find out the voltage gain for this one. AV is equal to voltage gain. AV is equal to minus gm into. So in previous case, just we will take only previous place we will take resistance is that is nothing but voltage gain is depends only on RD value, but this is only one RD, right? So but if we go for in this case, it is also having some resistance. That means PMOS is also act as some resistor. At the same time, NMOS is also act as some resistor. Therefore, total resistance is equal to RDS by 2. So RDS1 into RDS by 2. Therefore, you will get RDS2. So why? Because this is suppose if you are taking a point, so this resistance RDS2. So parallel of this one, RDS into RDS2 divided by 2 RDS. Okay. So therefore you will get these two get cancelled. Therefore you will get only RDS by 2. So that is a voltage gain. So the negative sign is nothing but obviously it is the current is in the opposite direction. Just you will take the negative sign in this case also. Okay. Minus GM into RDS by 2. Suppose in case of small signal analysis, you will get that kind of a clarity, right? So the current direction is like this. So that is nothing but negative minus GM into. Just we will take how the variations are to take this. So here the active element is nothing but having a biasing. If we replace the active element with the current mirror circuit, so if there are any variations in the corresponding circuit, there is a problem. Suppose if you are replacing this complete part with the current mirror, therefore that circuit is very robust and practical and more stable for variations in the parameters. So obviously the VGS is also depends on the supply voltage. Is there any variations in the corresponding VTH value, that is also affects the drain current is also. That means the MOS transistors also varies the values with respect to the parameter variation. Parameter means the internal dimensions of the device. It may be VTH value or maybe length of the transistor, width of the channel. So these are all also affects the corresponding variations in the drain current also. So that is also very important take. So here we will replace the corresponding active element with a current mirror. We can get the stable circuit or stable output current. So that is a very important. So that is a basic necessity of the biasing in case of the MOSFET also. At the same time, suppose if you are observing in case of the common in case of the common source configuration, just to common source, will take the common drain point, I feel like that. So that point is already discussed, I think. Common collector in case of the common drain configurations also. Just we will take the biasing like this, just VDD. So in this case, if you are taking the I biasing, okay, this is nothing but output resistance or not, some input value Vin, at the same time biasing value VGS. So this is the ground, this is the input value. So in this case, what happens is nothing but this I biasing. This is generally called the I biasing. So I biasing, here the biasing element is a current source. This biasing element is produced independent on the corresponding RL value. Without depending on this one, just if you produce output value, then it's okay. So instead of I biasing, just if you are replacing it with a current mirror circuit, it gives a better clarity for this, better response and better. It is also stable system as well as the current is also constant value. So that is a very important thing in this case. Okay. So thank you guys. Thank you for watching GMK tutorials.